Once you have grasped how calibration is performed from watching some of the other videos in this series, you may have a test system where the vector network analyzer is integrated and requires the operator to perform the calibration at regular intervals to ensure the best possible performance. This video will introduce you to how you might accomplish this using some pre-built Python driver code, creating the full example line by line in Visual Studio Code. Here we show a list of comments that outline the basic steps needed to perform a one-port calibration. To access the driver code, we start by importing the Bird VNA class structure that resides in the driver files. We can then instantiate a VNA object. We need to initialize the driver object, passing in the instrument resource string. If you want to start your calibration from the default state, you can use the preset method to do so. While channel 1 and trace 1 are the defaults, here we show how these might be modified if you needed to do so. Your calibration should start so that the frequency range and point count are specific to the test to be performed. Note that when you hover above the property or method, you will get the driver's context-sensitive help, sometimes referred to as signature help. You need to define which calibration kit will be used. The integer value you pass into the calkit select attribute aligns with the index value for the kit as defined in the list available within the VNA software user interface. In this case, it will be the manual standard with the SMA connectors. We add in code that disables any active cal. Because we issue the preset command, this is not necessary, but we show it here for the purpose of exposure. We can then set the characteristic impedance of the test setup. We need to define what calibration method will be used. Note that we can access our context-sensitive help to help us determine what to pass as the first argument to achieve the one-port calibration. We then pass a 1 as our second argument to specify that the calibration will be specific to port 1. Let's add an input statement to notify the operator that the program is expecting the open standard to be connected prior to making a measurement. After the operator responds, the measurement is made. Note how we include the OPC query method on the next line to allow enough time for the measurement to complete before moving on to the next step. We repeat similar operations for the short and load devices. Upon successful calibration, we will need to perform the save operation to ensure the calibration coefficients are preserved in active memory. While this will also enable the calibration, we add the command that specifically enables it here just to give it some visibility. If this were the last thing our full program were to do, we would want to clean up by releasing the Visa instrument resource with a call to the close method. Let's now look at the code in action while running in debug mode. When we step over the initialize then preset commands, we can see the VNA transition to remote operation. We can then run through the configuration commands to get to the point where we are instructed to make the device connections one at a time. Upon completion, you will then still be able to access the VNA UI to perform any additional checks you may find necessary. For more information on how to use your Bird Vector Network Analyzer, check out other videos on the Bird YouTube channel.